Welcome to this explainer, where we're diving into a genuinely fascinating shift in biomedical engineering. Today, we're unpacking a totally paradigm-shifting device called the SoftFoot Pro. You know, when we hear the phrase high-tech medical device, our minds almost immediately jump to microchips, complex algorithms, and digital interfaces, right? But what if the next massive leap forward in prosthetics isn't about adding more technology, but actually stripping it away? Well, that is the exact core mystery we are unpacking today. Let's get into it.
So when we think of high-tech prosthetics, we usually imagine all these complex electronics. We picture whirring motors, heavy batteries, and AI making constant micro-adjustments. We've kind of been trained to equate progress with adding more computational power. But the reality of the SoftFoot Pro is just entirely different. It removes all of those electronics, it's completely passive, highly flexible, and 100% motorless. And yet, despite lacking a single computer chip or battery pack, it somehow behaves far more like a real biological human foot than many of the highly motorized systems out there. It's wild.
Part 1. The illusion of complexity.
To really understand why a motorless design is such a monumental breakthrough, we first need to look at the hidden problem with traditional prosthetic feet, and honestly, just the sheer everyday complexity of walking. It's something most of us do without a second thought, but mechanically, it is an absolute marvel. Walking isn't just a flat, repetitive motion on a perfectly smooth treadmill. Every single step we take changes based on the surface beneath us. Soft sand absorbs the energy of your step entirely differently than concrete does. Grass deforms and squishes under your pressure. Climbing stairs demands a highly controlled, specific ankle rotation. And walking on a rocky hiking trail shifts your entire center of balance in a fraction of a second. The environment is just constantly throwing unpredictable physical variables at us.
Now, most advanced conventional prosthetics try to solve this wildly unpredictable terrain problem with brute force technology. They often rely on stiff, rigid structural parts, heavy battery-powered actuation, and pre-programmed response patterns. Basically, they have software that tries to guess what the terrain is and react accordingly. But this creates a really frustrating gap between natural biological motion and stiff artificial motion. The result? The user is forced to consciously compensate for what their biological foot would have just done automatically. They literally have to overthink their own steps.
Part 2. The genius of biology.
Before we can re-engineer a foot, we have to look at the blueprint nature spent millions of years perfecting. Think about the number 26. That is exactly how many individual bones are working together in a single human foot, operating alongside 33 flexible joints. It's definitely not one solid block of bone. It's a highly articulated network of distinct pieces, constantly moving and sliding in relation to one another.
But wait, it gets even crazier. That incredibly complex bony structure doesn't just sit there. It's dynamically powered, stabilized, and tensioned by more than 100 muscles, tendons, and ligaments. It's essentially a living web of biological cables constantly pulling, releasing, and adapting to the forces exerted upon it.
Because of this stunning anatomy, your foot isn't just doing one simple thing. It acts as a shock absorber when your heel strikes the ground. Then it instantly turns into a rigid lever to propel you forward when you push off your toes. Plus, it acts as a highly sensitive balance system and serves as a crucial sensory interface, sending constant feedback about the ground straight up to your brain. It does all of this simultaneously in literally a fraction of a second. Replicating this level of multifunctionality with rigid mechanics and motors is frankly incredibly tough.
Part 3. The SoftFoot Pro Revolution.
This brings us directly to the SoftFoot Pro, an innovation developed in Italy, which stops trying to outcompute the human foot and starts trying to actually understand it. I want you to seriously consider this question for a moment. What if the best prosthetic foot isn't the one that rigidly controls movement with sensors and motors, but the one that naturally allows it to happen? This subversion of expectations is the massive paradigm shift the SoftFoot Pro introduces. It's a shift from active, forceful control to passive, natural permission. This whole approach is rooted in a fascinating field called biomimicry. That's the practice of learning from nature's evolutionary solutions to solve human engineering challenges. The engineers behind SoftFoot Pro basically realized that nature had already spent millions of years optimizing how living organisms move across complex environments. So, instead of competing with that evolution by throwing microchips at the problem, this device translates that natural structural behavior directly into an artificial, waterproof, and highly flexible mechanical design.
So, here is the magic. By focusing on what engineers call mechanical compliance, meaning the ability of the structure to bend under a load and then return that energy, the foot absorbs and redistributes forces naturally. Just like a real foot, when it hits a rock or uneven ground, the flexible structural elements bend and adapt to that specific shape right on contact. The massive benefit here? There are absolutely no software updates to run, no battery management to worry about, and zero electronic latency. It is just pure physics and geometry doing all the heavy lifting.
Part 4. Why less is actually more.
Now, at first glance, a motorless design sounds like a step backward in the digital age, right? But it brilliantly solves major engineering hurdles all at once. Without heavy batteries, you immediately get a drastic reduction in weight, which saves the user from daily fatigue. By ditching the complex electronics, you instantly boost reliability. I mean, there are no motors to seize up if you step in a puddle or walk on a sandy beach. It requires zero charging, relying purely on the user's biomechanics. And best of all, it physically adapts to the ground in real time.
If you take absolutely nothing else away from this explainer today, let it be this core concept. Adaptation is not computed, it is embodied. The prosthetic isn't using a microchip to calculate how to adjust to a rock. The physical structure and geometry of the foot itself naturally wrap around that rock the exact moment it steps on it. The intelligence of the device is baked directly into its physical shape and materials.
Part 5. Real-world testing at the Cybathlon.
Because, let's be real, theory and clever geometry are one thing. But how does it hold up when life gets messy? Well, the SoftFoot Pro has proven itself in intensely competitive environments, like the Cybathlon. This is an event designed specifically to challenge assistive technologies with real-world obstacles. We're talking about navigating highly uneven terrain, stepping over unpredictable obstacles, and dealing with real movement constraints that a user would actually face in their daily life. Testing out here is vital because it separates theories that just look good on paper from technologies that actually behave well outside the lab. And the SoftFoot Pro's biomimetic design completely thrived in these unpredictable constraints.
Part 6. The future of medical design.
The success of this seemingly simple design at grueling events really hints at a much broader, exciting trend taking shape across the entire field of biomedical engineering. For the longest time, the dominant mindset was to rigidly control biology. We assumed that with enough sensors and computational power, we could force the body to walk perfectly. But now, we're moving toward cooperating with biology. Engineers are focusing on adaptive structures that seamlessly blend into the body's natural logic. Instead of fighting nature with electronics, they are creating devices that work with the physical mechanics we already have.
Moving forward, this tells us we may be entering an entirely new era. An era where prosthetics are defined by bio-inspired mechanical intelligence rather than just raw technological complexity. We are definitely going to see hybrid systems that beautifully combine these adaptive, passive elements with active ones, but only where truly necessary. This means a massively reduced reliance on batteries and ultimately a much greater, more comfortable integration with natural human movement patterns. It proves that sometimes the most advanced solution isn't the one with the most wires, but the one that best understands how biology already solved the problem millions of years ago.
I'm going to leave you with this final, provocative thought from our explainer today. How can we design technology that behaves like nature without needing to outsmart it? The SoftFoot Pro isn't just an incredible prosthetic. It's a profound reminder that the most powerful technologies of our future might just be the ones that quietly and beautifully disappear into the natural logic of the human body. Thanks for joining me on this deep dive, and keep questioning how we define true innovation.